Good morning, afternoon, or evening, cats and dogs. It's halftime of the Notre Dame game, so time to record another video. This video will focus on the lesson 6.8 guided notes on solving two-step inequalities. We'll also graph our solution as well. So let's begin with question number 1. We did already see this question in class for at least some of the classes, but it's not a bad idea to start here. So in number 1, we've got 6x plus 15 is greater than 9. We're going to solve this exactly the same way we would solve a two-step equation. So we're going to solve this in exactly the same way. So what we want to get rid of first is that constant of 15. We know we're adding 15. The inverse of adding by 15 is to subtract 15. So let's do that to both sides. That's going to get us 6x is greater than 9 minus 15, which is negative 6. We finished by dividing both sides by 6. Now, since we divided both sides by a positive value, we do not need to flip the inequality symbol around. So we end up just getting x is greater than negative 1. Now, we do want to graph this on the number line. Keep in mind, we want to have 3 numbers on our number line. We've got negative 1 in the middle. Negative 2 is smaller to the left. 0 is bigger to the right. And we'll have an open circle because it's not equal to, it's greater than. And we are going to shade to the right since it's the greater than symbol. Numbers that are greater than are going to be to the right. So let's go ahead and make this blue for us. There we go. Good. All right, so greater than negative 1, we'll shade to the right. And that is our number line. Again, this shows all the possible numbers that are solutions to our inequality, like 0 and 1 and 2 and 5.5, for example. Numbers that are greater than negative 1 will make this inequality true. All right, let's take a look at question number 2. We notice that our variables on the right-hand side, we'll deal with that at the end. The first thing we want to do is get rid of this minus 4. The inverse of that is to add 4 to both sides. That's going to get us negative 12 is less than 6r. We'll divide both sides by 6, and that's the inverse of multiplying by 6. We've got to remember those inverse operations. We divided both sides by a positive again, so no need to flip the inequality symbol around. Negative 12 divided by 6 is negative 2. Now, we can leave our solution like this. This is not wrong. You're not going to lose points for this, but I do suggest rewriting it with the variable on the left. So I do suggest putting the r on the left, the negative 2 on the right, but if you flip both the variable and the number and you want to keep the meaning the same, you also have to flip that symbol. It's not the same as flipping just the symbol when you multiply or divide by a negative. If you flip everything, it keeps the meaning the same. So r is greater than negative 2. That's going to be another open circle. And since it's greater than, we're also going to shade to the right. So let's go ahead and shade to the right here. There we go. Good. So our number line is going to look like this. And again, we need to have a minimum of 3 numbers on our number line. Some students have asked me, do we have to count by ones? I don't understand what to count by. Well, it looks just like a snapshot of a number line with negative 2 on there. I usually just count by ones, or in the next question you're going to see we're going to be counting essentially by tenths, but most times we're just going to count by ones. All right, so number 3 does involve some decimals. No big deal, though. We treat this exactly the same. So we have 10.5 is greater than b over 7 plus 6.8. So we want to get rid of that constant first, that plus 6.8. That's the last thing that's happening to the variable. It's the first thing we undo. So the inverse of adding by 6.8 is to subtract 6.8. And here's where you really want to have your calculators handy. We're going to do 10.5 minus 6.8. That's going to get us 3.7. Now remember, I asked someone this question last week and they didn't know what the fraction bar represents. It represents division. So the inverse of division is multiplication. We're going to multiply both sides by 7. So in your calculators, you're going to be doing 3.7 times 7 to get 25.9. Now, the variables on the right, I do suggest rewriting it with the variable on the left. So if you're rewriting it, you flip the variable to the left, the number to the right, and you've got to flip-flop that inequality symbol as well. So this is b is less than 25.9. You can also read it from right to left, like b is less than 25.9 when you go to graph it. This is also going to be an open circle here. You're going to notice I counted by tenths, which you don't have to, but I did 25.8, 25.9, 26. You want to make sure you're counting evenly. This one, though, since its b is less than 25.9, we are going to shade to the left. So let's go ahead and shade to the left here. There we go. All right, so it's going to look like this. Open circle again, shade to the left since it's less than. All right, let's take a look at number 4. So we have k over negative 5 minus 10 is less than or equal to negative 8. We want to start by getting rid of that minus 10. The inverse of subtracting by 10 is to add 10. So we end up with k over negative 5 is less than or equal to 2. Negative 8 plus 10 is 2. Now let's multiply both sides by negative 5. But remember, when we multiply or divide both sides of an inequality by a negative, we need to flip the inequality symbol around. So the less than or equal to symbol becomes the greater than or equal to symbol. Again, that's anytime we multiply or divide both sides of an inequality by a negative. We are going to put a closed circle here at negative 10 since it's equal to, since it's greater than or equal to. And since it's greater than or equal to, we are going to be shading to the right. So let's go ahead and shade to the right here, get that thicker line. There we go. Good. Again, we want to make sure our final solution is what we use to graph our solution. It's all numbers greater than or equal to negative 10. Way to check your solution is to choose a number greater than or equal to negative 10, like 0 is a great one to use. Plug 0 in for k. 0 divided by negative 5 is 0. 0 minus 10 is negative 10, and negative 10 is less than or equal to negative 8. Now, in numbers 5 and 6, the variable comes after subtraction. And if you remember, anytime the variable comes after subtraction, we should add the opposite. So in fact, I rewrote this equation as 8 plus negative 1t is less than negative 10. The inverse of adding by 8, that's what we want to get rid of first, is subtracting by 8. A lot of students try to add 8 to both sides, and that's just not correct. So we're going to get negative 1t is less than negative 10 minus 8 is negative 18. The inverse of multiplying by negative 1 is to divide by negative 1. And because we divided by a negative number, we need to flip that inequality symbol around. And this is going to get us t is greater than, negative 18 divided by negative 1 is going to get us positive 18. Now this one is going to be an open circle for us. Bear with me, my computer is getting stuck there. We're going to have an open circle again because it's greater than and not equal to in this case. And again, since it's greater than, we're going to be shading to the right. So let's go ahead and add our arrow in there. Feel free to pause the video at any time if we're going a little too quickly. We did the same thing though with one-step and two-step equations, so we're just mixing it up here with inequalities. We're going to solve them exactly the same. But you do need to remember a few key things. Again, anytime we multiply or divide by a negative, we flip that inequality symbol. We also need to remember that anytime the variable comes after subtraction, to rewrite it by adding the opposite. And in fact, we're going to do that also on number 6. So number 6, I'm going to rewrite this guy as 7 plus negative 2b is greater than 11. Again, I want to get rid of my constant, my plus 7. The inverse of adding by 7 is to subtract 7. That will get me, excuse me, negative 2b is greater than 11 minus 7, which is 4. Then divide both sides by negative 2, and again, we're dividing by a negative value. So that means we're going to flip our inequality symbol around. So it was greater than, it becomes less than. 4 divided by negative 2 is negative 2. Since it's the less than symbol and not equal to, it's going to be an open circle. And again, for that final circled solution, since it's less than, we are going to shade to the left. We've seen all of these things before with both equations and one-step inequalities, so it's nothing new. So we're going through these steps pretty quickly, but if you're struggling with any of these things, this is where you want to get some help. All right, we're going to move ahead to our last 3 questions. In fact, only 2 because I'm going to skip over number 7. You don't have anything quite that difficult on your test or your quiz or graded classwork or anything like that. I just really want to make sure we see the kind of problems you will definitely see on your test. You might see questions like number 7 in the future, but for right now, we really want to just focus on pretty standard two-step inequality questions. So number 8, this one's a pretty nasty problem in and of itself. We want to get rid of that minus 5, so the inverse of subtracting by 5 is to add 5. Negative 8 plus 5 is negative 3, so we have negative 3 is less than r over negative 2. The inverse of division is multiplication, so we're going to multiply both sides by negative 2. But when we do that, we need to make sure that we flip our inequality symbol around. So from here where it was less than to here, I'm going to go ahead and highlight that. From this step where it was less than, I flip it to greater than because I multiplied both sides by negative 2. But I do also suggest rewriting it with the variable on the left. I would do those as separate steps. With experience, you might be able to get right to this final solution a little quicker. That being said, this is the first time we're seeing this, so don't skip steps here. When we rewrite it, we move r to the left, 6 to the right, and we flip the symbol as well. Keep in mind from here to here, where we only switch the symbol, that changed the meaning of our problem. But from this line to this line, where we moved everything, we flipped everything around, it doesn't change the meaning. In fact, if you put, and I'm going to circle this, if you put this as your solution, you would get full credit as well. I think the harder part comes from when you go to graph it. It's going to be an open circle. But students who leave their solution like this top circle here, a lot of times are going to shade to the right, and we actually want to shade to the left because r is less than 6. So let's go ahead and shade to the left. And it should look like this. All right, let's take a look at one more, and then I have 2 problems for you to try on your own just to get some additional practice on this concept. So we've got 5a minus 7 is greater than or equal to 43. Let's start by adding 7 to both sides. That's going to get us 5a equals 50. We'll divide both sides by 5, and since we're dividing just by a positive value, there's no need to switch anything around. You'll get a is greater than or equal to 10. So again, 3 numbers on the number line. I already had the number line set up here just to make things easier on myself, so it didn't take 20 minutes to create a video that could have been done in about half the time or less. So it's a closed circle because it's equal to in this case, and it's greater than or equal to. So we're going to be shading to the right. So let's go ahead and shade to the right here. Looks good. All right, I do want to give you a chance to try 2 questions on your own. So at this point, I want you to go ahead and pause the video, give these 2 questions a try, solve them and graph them. I will tell you for both of these problems, you will have to flip the inequality symbol around. And I'm also going to remind you for number 2 that you should rewrite this as 4 plus negative 2x is less than negative 12 as your first step. Why? Because x comes after subtraction. When you're ready, start the video again, and we'll take a look at these 2 questions. All right, I hope you've taken a look at these 2 questions at this point. Let's go. First thing we're going to do in number 1 is subtract 2 from both sides. Negative 16 minus 2 is not 14 or negative 14. It is negative 18. The inverse of multiplying by negative 3 is to divide by negative 3. So when we do that, we are going to get x is less than or equal to. Notice how I flipped my symbol since I divided by a negative. Negative 18 divided by negative 3 is positive 6. This one's going to be a closed circle because it's less than or equal to. And since it's less than, we're going to shade to the left. Remember, you have to know what these symbols mean. Keep in mind that the less than symbol looks a lot like an L sort of tilted on its side, or more of like an italicized L. So it looks like an L, and that's our less than or equal to symbol, and we shade to the left. Lots of L's there. Number 2, I would add the opposite and rewrite this as 4 plus negative 2x. You want to get rid of the plus 4 first, though, by subtracting 4 from both sides. That's going to get us negative 2x is less than negative 16. Negative 12 minus 4 is not 8. It's not negative 8. If you don't trust me, check the calculator. Divide both sides by negative 2. When we divide both sides by negative 2, we flip that symbol since we divided by a negative. So the less than becomes a greater than, and negative 16 divided by negative 2 is going to get us 8. So our solution is x is greater than 8. This is going to be an open circle in this case because it's greater than and not equal to. And since it's greater than, we are going to be shading to the right. So let's go ahead and shade to the right. and it's going to look like this. All right, this is something we're going to continue to review throughout this week as well, so we will be doing some more practice with this. But if you're really, really struggling, if you have no clue where to start with these problems, you definitely need to get some support and need to get some help, because your entire test is on 1- and 2-step equations, as well as 1- and 2-step inequalities. So let's begin by taking a look at numbers 10 through 14. These questions ask us to write an inequality to represent each of the following sentences. Number 10 says 3 times a number increased by 4 is at most negative 62. So the only new part here is our inequality, and is at most is going to represent our inequality. If we say is at most, don't forget we have our inequalities guided notes that has a table which goes through a lot of these phrases and matches them to the appropriate inequality. Is at most is going to be our less than or equal to symbol. The rest of this here, 3 times a number is obviously 3 times a number, multiplication. Increased by, we know, is addition. So we can represent this as 3n, or any variable we choose, plus 4 is at most is less than or equal to negative 62. Number 11, the quotient of a number and negative 5 increased by 1 is at least 7. So again, the phrase that represents our inequality here is at least. At least is greater than or equal to. We also have to remember that the word quotient means division. So we can represent this as n, or any variable we choose, over negative 5. Increased by 1 is plus 1, and at least is greater than or equal to 7. All right, let's take a look at number 12. The product of negative 2 and a number, less 6, is no less than negative 18. That's not a phrase we see a lot, but is no less than represents our inequality. Is no less than means it needs to be greater than or equal to negative 18. We also need to remember that the word product means multiplication, so we can represent this as negative 2n. Less 6 means to subtract 6. We're not talking about the less than symbol here. And then is no less than is going to be greater than or equal to negative 18. Taking a look at number 13, the quotient of a number and 3 minus 2 is no more than negative 12. So is no more than is going to represent our inequality symbol. That's going to be less than or equal to. Remember, quotient means division, so we can write n over 3 minus 2 is going to be that next part, and then is no more than, again, is our less than or equal to negative 12. Finally, from this group, our simple 2-step inequality questions. Twice a number increased by 4 exceeds negative 20. So the word exceeds is going to represent our inequality here. That's greater than. Twice a number is 2 times a variable n, increased by, again, addition. So we can have 2n plus 4 is greater than negative 20. All right, let's go ahead and take a look at numbers 15 and 16 as well. These are a touch more challenging than the previous problems, but this is going to incorporate our 1-step inequalities with 2-step inequality problems. So number 15, let's read through it. You earn $2.75 for every newspaper that you deliver, plus a salary of $15 each week. Write and solve an inequality that can be used to determine how many newspapers you must deliver if you plan on earning $180 each week. Interpret your solution. All right, so first things first, as always, let's identify our unknown. It asks us to determine how many newspapers you must deliver, and I'm going to represent that with the variable n for number of newspapers. Now, we don't really have a word or phrase here that indicates our inequality, but we do know that the total amount we want to earn is $180. So we want to think, do we want that to be less than 180, less than or equal to, greater than 180, or greater than or equal to? Well, if you plan on earning $180, my guess is you want to earn at least $180, which is our greater than or equal to symbol. Now for the rest of the problem, so we're going to have greater than or equal to 180, which we'll show or reveal here in a moment. But on the other side, we know it's 200, wow, that would be a lot, $2.75 for every newspaper. Keep in mind, n represents the number of newspapers. So we can represent that as $2.75 n. Then you also get a salary of $15 each week. So we can represent this as $2.75 N plus 15. And again, we want to earn at least or greater than or equal to 180. Think about what makes sense for the problem. In this case, greater than or equal to. Now it's just a two-step inequality. So we want to get rid of this constant. The inverse of adding 15 is subtract 15. That's going to get us $2.75. N is greater than or equal to 165. Let's divide both sides by $2.75, and you are going to get N is greater than or equal to 60. Now we do need to interpret our solution here. So N represents the number of newspapers, so in this case we can say something similar to this. You must deliver at least 60 newspapers, you could say in a week, if you want to earn $180 each week. So we need to deliver a minimum of, or at least 60 newspapers each week if you want to earn $180. All right, kind of like with our one-step equations, I do think some people find the two-step inequality is also a little bit easier to work with. Once you've seen one-step and two-step equations, the two-step seem a little bit simpler. Same way here, the one-step inequality word problems. Now we get to our two-step inequality word problems. Sometimes I think students find them to be a little bit easier now that they've already seen those one-step equations and inequalities. All right, let's read through number 16, our last question for this video. Barb brought her car to the mechanic. The mechanic said that the job was going to cost at least $425 for parts and labor. If the cost of the parts was $125 and the mechanic charges $50 per hour, write and solve an inequality to determine how many hours the mechanic is planning to work on the car. Interpret your solution. So first things first, let's identify what we're trying to find. In this case, we want to determine how many hours the mechanic is planning to work on the car. So I represented that with the variable h, so I said h equals number of hours. Now, we do have a phrase here, excuse me, that's going to represent our inequality. We know that the job itself is going to cost at least $425. That's greater than or equal to $425. We also know the cost of the parts was $125. That's a flat fee or flat rate. It's not dependent on the number of hours. And the mechanic charges $50 per hour. Keep in mind, h represents our number of hours. So the left-hand side of this is going to look like this. 125 plus 50 times h. Then at least 425 is greater than or equal to 425. Now, I think when I wrote this, I actually put the 125, our constant or flat fee second. It doesn't matter because addition is commutative. All right, let's go ahead and solve this. So let's subtract 125 from both sides using those inverse operations. We get 50h is greater than or equal to 300. Divide both sides by 50. And you should get h is greater than or equal to 6. Now don't go anywhere yet because we need to interpret our solution. I also did put an extra practice or independent practice problem in this video so that you can take a look at that as well on your own, because I think it's important to get that practice. And it's going to be very similar to this question. So let's interpret this. H represents the number of hours, and if it's greater than or equal to 6, then we can say something similar to as follows. The mechanic will work on the car for a minimum of 6 hours or for at least 6 hours, something similar to that. They did use the phrase at least in the problem, so that might be the easiest to go with. But the mechanic will work on the car for at least or a minimum of 6 hours. All right, so I want you to try this question. Go ahead and pause the video. Read this question, give it a try, set up the inequality, solve it, and interpret your solution. I know it doesn't say to interpret it, but we're going to do that anyway. When you're ready, restart the video. Again, this is our last question for this video, but restart the video and take a look at your solution and see if it's correct. All right, so hopefully you've taken a look at this problem. Let's read through it. Christian took his car to the mechanic. The mechanic said that the job was going to cost at least $705 for parts and labor. If the cost of the parts was $525 and the mechanic charges $45 per hour, write and solve an inequality to determine how many hours the mechanic is planning to work on the car. So we're trying to determine again how many hours the mechanic is planning to work on the car. You're going to notice the same wording as the last question. So my variable is H equals number of hours. Now, we also know that it's going to cost at least $705. That's the total amount of this entire job. So that's greater than or equal to 705. The parts were $525, and the mechanic charges $45 per hour. Keep in mind, H represents the number of hours. So our inequality will look like this. 45H for the $45 per hour plus 525 for the parts is greater than or equal to 705. Let's go ahead and subtract 525 from both sides to get 45H is greater than or equal to 180. Divide both sides by 45, and that's going to get us H is greater than or equal to 4. So we can expect the mechanic to be working on the car for at least 4 hours, since the number of hours is greater than or equal to 4. All right, keep in mind we'll probably see some more practice on this prior to taking our unit test, but it's good to at least see these pretty standard two-step inequality questions. So let's begin with question number 17. Elise wants to take her friends to the movies. She wants to spend less than $139. Each movie ticket costs $9.50, and she plans on spending $25 on food. A, write an algebraic inequality that can be used to determine how many movie tickets she can purchase. B, solve your inequality from part A. C, explain what the solution from part B means. And D, can Elise afford to buy 12 movie tickets? Explain. So this is going to look very, very similar to your large word problem that finishes up each unit test. And it's going to be very similar to the one that you're going to see on your unit test. In fact, it's the same wording, although a different scenario, different numbers. And in this question, you're going to see it says she wants to spend less than $139. It's going to be worded exactly the same way on your test, which in my personal opinion, I didn't create the test. I'd rather say she has $139 to spend, which would mean she would spend less than or equal to $139. But it is very specific here. It says less than. So that's what we're going to go with because that's the wording on the common assessment that we're going to take. So first things first, let's identify our unknown. In this case, we are trying to determine how many movie tickets she can purchase. And keep in mind, you might have to read the question more than once to remember what we're trying to find or figure out what we're trying to determine in this case. All right, so we're going to go ahead and define a variable to represent that. I chose T for our variable. That's the number of tickets she can purchase. Now we're going to put this into an inequality, very similar to what we saw in our last video. So let's go ahead and break this down. We know that she wants to spend less than $139. So you're going to see less than $139. Again, in a real life scenario, we would probably set that up as less than or equal to, but it is very specific in this question, and that's what we're going to go with. So we also know that each movie ticket is going to cost $9.50. And I'm going to put a little bit of blue under here because each movie ticket is our variable T. So I'll go ahead and type a T right there. So we can imagine we're probably going to put the $9.50 and the T together, $9.50 per ticket. We also know that she plans on spending $25 on food. So the rest of this inequality is going to look like this. $9.50 T for the tickets, plus $25 for the food, and again, we want that to be less than $139. And I realize most real life situations we're going to do less than or equal to. Let's just go with what the problem says here. Let's solve this for part B. So we're going to subtract 25 from both sides to get $9.50 T is less than 114. Divide both sides by $9.50, and that's going to get us T is less than 12. So when we go to explain what this means, we need to be very specific. Since its T is less than 12, Elise can purchase less than 12 tickets. So finally in part D, and again, don't be afraid to pause the video if you fell a little bit behind with that work. I'm going through it pretty quickly, but you can pause it at any time. Can Elise afford to buy 12 movie tickets? Well, in this case, no, because the inequality is less than. That means that she can only purchase less than 12 tickets, which is not equal to 12 tickets. So I don't care how you word it as long as you explain why she cannot buy 12 movie tickets. I said here the inequality is less than, and since she wants to spend less than $139, she cannot purchase 12 tickets. In fact, if she purchases 12 tickets, she'll be at exactly $139, and she wants to spend less than that amount. All right. I can also guarantee that you're going to see a question similar to that when we do our review sheet. I did put one very similar to it on the review sheet, so we would get some additional practice with this concept. All right, let's take a look at number 18. Samuel went to the park with $18. Admission costs $4, and each ride costs $1.50. If Samuel bought a drink for $1 and bought nothing else while at the park, what is the maximum number of rides that Samuel can ride? So this is one of those multiple choice word problems that you really do have to do work for. You can't just, guess a solution or anything like that. You want to actually show the work. So first things first, we know that admission costs $4. And Samuel bought a drink for $1. So I did set up sort of a little equation here. The admission plus drink is $4 plus another $1. So he did spend $5. That's not really dependent on how many rides he rides. We do know that we're trying to figure out the number of rides. I did not specifically define a variable here, but I can do that. Let's make that not look so bad there. There we go. So I'm going to say R equals number of rides. And then I would actually physically set up an inequality and solve it. So we know that Samuel went to the park with $18. That means he wants to spend less than or equal to $18. He spent $5 between admission and a drink. And we also know that each ride costs $1.50, and R represents the number of rides. So let's go ahead and put this together. I actually wanted that to be blue. There we go. We got a lot of colors going on here. We got a rainbow of colors. So the way I would set this up would be the $5 between the admission and the drink, plus $1.50 per ride, so $1.50 times R. And then again, since he has $18, we want to spend less than or equal to 18. Let's solve this. We'll subtract 5 from both sides, and we get $1.50 R is less than or equal to 13. We'll go ahead and divide both sides by $1.50, and that's going to get you 8.6 repeating. Now, your calculator might show 8.6666666, a bunch of sixes, followed by a 7. There's not really a 7 there. Your calculator just has to terminate or end that decimal at some point, so it's going to round that last digit up to a 7. But it's really tempting to say, oh, I got R is less than or equal to 8.6 repeating rides, but you can't ride 2/3 or 0.6 repeating of a ride. So this doesn't make sense for this situation. Sometimes decimals do, but this doesn't make sense. That doesn't mean our solution is wrong, which sometimes students think, well, it has to be wrong then. What we want to think is what whole number of rides fits this inequality. So 9 rides, well, 9 is not less than or equal to 8.6 repeating, so we can eliminate that. Now, both 8 and 7 do make this inequality true. They're both less than or equal to 8.6 repeating, but keep in mind we're trying to determine the maximum number of rides that Samuel can ride. He can ride 7, but the maximum number he can ride is actually 8. So again, this is a really good example of a multiple choice question that's a word problem that you can't just look at it and guess a solution. I would definitely set up that inequality, solve it, and figure out which solution makes sense. And you're going to have a problem really similar to this also on your unit test. So please make sure you pay attention to this problem in particular. And I believe I put a problem similar to this on your review sheet as well. All right, we have one last question to take a look at, number 19. So let's read through this. Philip is selling tickets for the school musical. He has already sold 20 tickets and can sell up to 12 tickets per day. If D represents the number of days and Philip wants to sell at least 86 tickets, which inequality represents this situation? Well, first off, we know that he wants to sell at least 86 tickets. All of these have 86 by itself on the right-hand side. We need to recognize that at least is greater than or equal to. So let's eliminate the choices that do not have greater than or equal to 86. This one does not. and this one does not. So we're now down to a 50-50 shot here. We've only got 2 possible choices. So the difference between these two is where the D is. D represents the number of days, because keep in mind, it says right here, D represents the number of days. So we know that he's already sold 20 tickets and can sell up to 12 tickets per day. So which number do you think the variable D goes with? Well, probably the 12 tickets per day. So which one has the D with the 12? Looks like choice B is the only one that makes sense here. So choice B is the correct solution. So this one's not quite as extensive as number 18, but it does really require you to read through and analyze this question. Again, I think multiple choice questions in a lot of ways are more difficult than the open-ended questions for students because they do typically require you to think. And the other 3 answer choices that are wrong are typically mistakes that students or even adults, for myself, I know I've made these mistakes sometimes, mistakes that other people will make when they're trying to find the solution. So you really need to read carefully. All right, keep in mind, because you have problems like this on your test, you're going to see some on your review sheet. That's really key to help prepare you for your test. So please make sure you look carefully at that. Please make sure you look carefully at these questions again as well. Thanks for listening.